Okay, I'm going to give you some characteristics of a function, and we're going to write the equation of that function as if it were a sine function. For example, let's say the amplitude is 2. Let's say the period is 2 pi. And let's say we have a phase shift of pi over 2. Now, since that's positive, that would be to the right. So we have an amplitude, a period, and a phase shift. So in general, we can write this as y equals a sine bx minus c. A is the amplitude, so I can drop into 2. Keep in mind it could have also been negative 2. The absolute value would still give you positive 2. The next thing I need to do is find the period. Well, the period is found by taking the original period of sine and dividing that by b. So since we end up with the same period, that means that the b would have to be 1. Okay, so there's no period change. Phase shift is found by taking the bx minus c and setting it to 0. We've now determined that this is x minus c, set to 0. So the phase shift is going to be whatever c is, and we're told that the phase shift is pi over 2. So now I know what c is, so y is equal to 2 times sine of x minus pi over 2. And let's look at another one. Let's say the amplitude is 3. The period is pi over 2. And the phase shift is 1/2 to the left. In other words, negative 1/2. Okay, so again, we know what A is based on the amplitude. Again, you could treat that as negative 3 if you want. The period is found by taking 2 pi divided by b. So let me solve for b in this equation. So pi times b is equal to 4 pi. So this means that b is equal to 4. So at this moment, we have y is equal to 3 times sine of 4x minus c. For phase shift, we're going to have 4x minus c set to 0. So the phase shift is c over 4. And the phase shift was given as negative 1/2. Okay, so solving for c, we have 2c equals negative 4. So that means that c is negative 2. So plugging our c back into the equation, y would equal 3 sine of 4x minus negative, so plus 2.